When we speak about matter, there are a few things we need to know. First, that there are several states of matter, and second, there's some properties of matter, either physical properties and chemical properties. And that's what we're going to look at today. So first of all, let's have a look at this idea that we have matter. In a previous video, I mentioned that when we have matter, we have what we call mixtures and pure substances. But when we talk about pure substances, we often have the three states of matter. So the first one is about a solid, the other one is a liquid, the other one is a gas, and further, if you go and continue in science, we can talk about plasma. So let's see the difference between all of them. When we think of solid, and let's think about water, that's often the one that we know about. So a solid, as part of solid water, is ice. So it has a volume, it has a mass, and it's very definite. Now if it happens you take that solid and you give it some energy, that the molecules in that solid will start moving a little bit more, and it will turn into a liquid. An example of liquid water is basically water. So here we have a water drop right here. If it happens from the liquid water, we increase the temperature a bit more, we end up with vapor, which is now a gas. And here we can find vapor in our atmosphere, and as this vapor goes up into the sky, it can actually crystallizes and create those clouds right here. And this is when we have a gas that turns into a solid. Now, interestingly enough, if it happens that you give more energy to gas, we end up with plasma. And here's an example where we have lightning going through the atmosphere and breaking down the actual molecule of water into its individual particles of H2O, so hydrogen and oxygen. So these are basically the three states of matter that we want to deal with in grade 9 and 10. Solid, liquid, and gas, and plasma is part of where we are. Often plasma, we can talk about it in space when we are talking about stars. Perfect. The next part I want to talk about is about physical properties. Physical properties, there are two kinds. The first one are the physical properties that we can see or we can observe with our five senses. So first of all, we have colors. So if we think of this, so let's see if we can use some of these. So here I have, so let's see, there we go. So here I have an example of a quartz crystal. It has a color, or if we have a marker, we can actually see colors here. There's also texture. If I take the brush here from my whiteboard, there's a texture here and we can feel it with our skin. There's also luster. Is it shiny or not? There's also part of the smell. So sometimes if you have a perfume or if you have food, sometimes you have some smells and you can notice it with your nose. Another one, your ears can actually notice some fizzing. I forgot to get a can of pop for you, but if you're at home and you have a can of pop or a bottle of pop and you open it, you can hear the pressure being released, but you also can hear the little bubbles of carbon dioxide being released out of the solution. So that's something we can hear with our ears. And there's also the malleability. Often the best one I have is if you have a piece of paper. Let's see if I can get that. So we have here a piece of paper. If I crumple it like this, we still have paper. So the property of that piece of paper is still the same, even though I bunched it in a small ball. The other one is brittleness. A good one for this one is if you have spaghetti and then you are breaking spaghettis. And I know some people say, no, you can't do that. But if you break spaghetti, you could notice it's about brittleness. Whereas there's some other materials that is at the opposite, where it can bend without losing its properties. So this is what we call qualitative properties. A fifth sense that I did not mention here is about taste. If you have salt in the kitchen, you can taste it. However, in the lab setting, or if you work in a workplace that is not a kitchen, which is clean, then we never want to use our sense of taste ever. That's for our safety. The other physical properties that we can work with are what we call quantitative properties. These properties can be, they're part of the matter and they're specific to pure substances and they can actually be measured with specific units. So, for example, if you have density, so the density here of this quartz crystal is different than, for example, that piece of ore from Sudbury, where we are extract copper and nickel from the earth. Another physical property will be the temperature. So we talked about the three states of matter. Depending on if we have ice, water, or water vapor, the temperature is different here. We have also the conductivity, and I have here, let's see if I can show it to you. If you have different metals, you have different conductivity, and we can use a multimeter like this to measure the conductivity of metals. And at the opposite of a metal being conductive, we have insulator. To be honest with you, we can look at some precious metal and use the conductivity of gold, for example, to know the alloy that we have at that time. Another piece of information is the melting point and the boiling points, both related to temperature in degrees Celsius. If you're in the United States, then it will be in Fahrenheit. We also have lengths in centimeter and kilometers. Now, if you are in the United States, it would be in inches and miles. And we also have volume. So here I have milliliters, I have liters, it could be ounces, could be gallons, or it could be centimeter cubes as well. These are physical properties that are given information for pure substances. One last thing that I want to share with you is the fact that we also have chemical properties of matter. And an example for that will be, so when there's a chemical property, that means that there's the possibility of creating new matter, and that's important. And how do we know there's something new? For example, you can have new color. So if you have a glow stick and you break it, new colors happen. That's a chemical change. You could have the creation of a gas that is happening. So, for example, if you have a gas engine and your car is running, and then you have the exhaust pipe and you have gases being produced, whereas you have fossil fuels to start with. You can also have a precipitate. That means that you can have two liquids, you put them together, and something happens, and coagulation or chemical reaction, and you have a solid to actually precipitate. That means that goes at the bottom of the container. And another option is also a change in temperature. The best example for this one will be, for example, if you are mixing, let's see, if you are, so for example, if you take magnesium and you put it in a flame, then you will, after a few seconds, magnesium will oxidize and create a very big bright light. If that's the case, there's more heat being produced. That's a change in temperature. Same thing with our star. We have fusion that creates energy. And if you do sport and you know what an ice pack is, when you have an ice pack, you have the crystals and you also have a pocket of liquids. When you burst the container of liquid and there's a mixing, then the ice pack becomes cold. That's an example of change of temperature or chemical properties of matter. I was looking for some examples that you might enjoy. One of them is reaction with oxygen. Let's see if I had my hammer earlier. Let's see, where is that hammer? I had it because I wanted to show. So as a geologist, I use a hammer in the field, and where is it? I had it a moment ago, and somehow it has vanished. It happens. Okay, let's see. I'm sure it must be somewhere. I had it earlier. So it's this one here, this one here. So it's not there. I don't know where it is. It happens. So the reaction with oxygen is if you have a piece of metal, you can think of a car. And if a car gets very, very old, then it will turn, so the metal will turn into a rusty metal, which is in a reddish color. That's a reaction to oxygen. That's a chemical property of iron. You also have reaction to water. If you don't feel very good, and sometimes some people are using Alka-Seltzer, you put them in water and then there's a reaction. It fizzes and then there's a reaction to water here. Could also be a reaction to acid or bases. The best thing is if you are, if you, let's say you have a stain, like a tomato sauce stain on your shirt, you have these little stick that sometimes tied and some companies are putting together, and you put the stick over the stain and the stain disappears. That means you had a long tomato sauce molecule or tomato molecule that broke down in something smaller, and then the color disappear. That's an example of a chemical change. We also have combustibility. So this idea here that if you have wood and you give it a little bit of energy, the wood would burn. That's an example of chemical property. And the other one, often we don't talk about this one, but it's toxicity. Toxicity is, for example, a poison. So if you are taking something, for example, alcohol, not good for you, you drink some alcohol, there's a reaction with your nervous system. There's a toxicity there, and that's not very good. Too much sugar is not very good. You know that in Halloween time, we have little kids walking around, they eat too much sugar, and then they get very hyper very quickly. That's an example of toxicity. And indeed, if the toxicity is too big, then sometimes we may have to go to the hospital, but it's because it's not very good. So these are example of properties of matter, and we just define what it is because as we are exploring chemistry, it's very important to have the good vocabulary to explain what we want to mean. On this, hopefully you enjoyed this video. If you have any questions or clarification questions about matter, put them in the comments below. I'm always happy to answer your questions. On this, have a good day. Take care.